Hello, my name is Beville. I'm the Design Manager for µModule products at Linear Technology. Today I'm going to talk about implementing scalable multi-phase power module regulators utilizing multi-phase self-clocking and very accurate current sharing. We'll be discussing electrical performance of 3 different designs: mechanical and package construction, thermal performance, and the power module being used in scalable designs. The first design I'm showing is a 24-phase 300 amp design that utilizes 12 LTM4620 modules with very accurate current sharing. As you can see, all 3 boards consist of 100 amp designs parallel all together to equal 300 amps. And notice the graph of very accurate current sharing across all the different phases. The next design shows a 100 amp single output 8-phase design with very accurate current sharing. This is a subset of the previous slide of 300 amps, this being 1/3 of the 300 amp design. This accurate current sharing offers a unique ability to scale power stages for increased power. This slide shows a single 4620 consisting of 2 independent regulators capable of 13 amps or combined as being shown for 25 amps with very accurate current sharing. This slide shows the unique features of clock phasing and frequency synchronization. The LTM4620 has onboard self-clocking that can be externally synchronized to an incoming clock, and it also has a clock out signal that can be phase programmed for multi-phase applications and parallel operation. The next slide here shows the unique packaging and construction of the 4620. As you can see, a cross-sectional view and a top-down view. The 4620 has a Linear Technology's proprietary QFN frame MOSFET stacking technique with both top and bottom effective heat sinking, which provides excellent thermal performance for the device. As you can see, the power MOSFETs connect to a copper heat sink as well as the power inductors. This provides effective heat sinking for both the bottom of the device and the top of the device. This provides excellent heat transfer through the bottom and top of the device when it is used in the parallel applications. This slide shows the block diagram of the 4620. The LTM4620 consists of 2 13 amp high performance synchronous buck regulator channels with very accurate current sharing. It also has a very accurate remote sense amplifier for measuring output voltage very accurately. The next slide here shows the LTM4620 package metrics. The LTM4620 is housed in a 15 millimeter by 15 millimeter by 4.41 millimeter tall package, which equates to about a little less than 6/10 of an inch on each side and less than 2/10 of an inch tall, which gives this device 143 watts per inch squared power density referenced off a 2.5 volt output. And as mentioned, the device has very good thermal properties, both good top and bottom heat sinking properties. And here is a reference schematic of the device. The next slide shows the LTM4620's thermal performance. The thermal pictures are shown depicting the difference of temperature rise with and without a heat sink with 200 LFM of airflow for a 12 volt to 1 volt at 26 amps and a 12 volt to 2.5 at 26 amps. As you notice in the slides, the temperature rises for the 12 to 1 volt application, which has a 26 watt, is only 40 C rise with no heat sink and 30 C rise with the heat sink. The bottom design shows the 12 volt to 2.5 volt at 26 amps, which equates to 65 watts, and you see a 50 C rise with no heat sink and 35 C rise with the heat sink. The next slide shows the conversion efficiencies for the 4620. The high efficiency performance for each individual output or combined as a single output is shown in the graphs. The conversion efficiency is around the 83% for low output voltages and above 90% for the higher output voltages. And as this graph shows, this is the single paralleled output of the 4620 with efficiencies very similar to the independent individual outputs. This slide shows the LTM 4620 output current derating curves. Unique package construction that enables high power conversion efficiencies and excellent thermal properties allows the 4620 to operate at maximum load currents at elevated ambient temperatures as shown in the graph. In summary, applications that require the use of one regulator to accomplish many different scalable power requirements can be very useful. The 4620 offers these kinds of flexible features with the noted features in the slide. For additional information, please visit our website at www.linear.com.